Greetings, dear students. Hope we are all fine. Elastic properties of solids. Solution to the assessments we were given in our last class. Assessment 1. A spring obeying Hooke's law has an unstretched length of 50 millimeters and a spring constant of 400 Newton per meter. Calculate the elastic potential energy stored in the spring when its overall length is 70 millimeters. Solution. Extension E is equal to 70 millimeters minus 50 millimeters, which will give you 20 millimeters. When we convert it to meter by dividing it by 1000, we are going to have 0.02 meter. Work done is equal to energy stored in the spring, which is also equal to half multiplied by spring constant multiplied by extension squared. Now, when we substitute the values for spring constant and extension and evaluate, we are going to have 0.08 Newton meter, which is also equal to 0.08 joule. Assessment 2. A 1 meter long steel wire of cross-sectional area 2.5 times 10 raised to power minus 6 meter squared is fixed at one end. A load of 15 kg is suspended from the free end so that the wire hangs vertically. The Young's modulus of steel is 2.0 times 10 raised to power 11 Newton per meter squared. Assuming that the elastic limit has not been exceeded, calculate the stress applied, the strain, and the extension of the wire. Take acceleration due to gravity to be 9.81 meter per second squared. Solution. Force on the wire is equal to weight of the load, which is equal to mass multiplied by acceleration due to gravity, which is equal to m times g. When we substitute the values for m being 15 kg and acceleration due to gravity being 9.81 meter per second squared, we are going to have 147 kilogram meter per second squared, which is also equal to 147 newtons. Now, stress is equal to force divided by area. When we substitute the value of force being 147 newtons and we divide by 2.5 times 10 raised to power minus 6 meters squared, we are going to have 5.88 times 10 raised to power 7 Newton per meter squared. B. Young's modulus is equal to stress all over strain. But from the question, we've been given that Young's modulus is equal to 2.0 times 10 raised to power 11 Newton per meter squared. Strain is equal to stress divided by 2.0 times 10 raised to power 11 Newton per meter squared. Now, strain, when we substitute the value of stress, will be equal to 5.88 times 10 raised to power 7 Newton per meter squared divided by 2.0 times 10 raised to power 11 Newton per meter squared being the value of Young's modulus. And when we do that, we are going to have 2.94 times 10 raised to power minus 4. Remember that strain has no unit. C. Strain is equal to extension divided by original length. Now the extension is also equal to strain multiplied by original length. When we substitute the value of strain as calculated in B, we're going to have 2.94 times 10 raised to power minus 4 multiplied by 1.0 meter. And when we do that, we are going to have our extension to be 2.94 times 10 raised to power minus 4 meter. God bless you. See you in our next class.